Israel, a nation long accustomed to conflict, faces a new reality where even its most advanced defense systems are not impenetrable. Strategic air bases like Nevatim and Tel Nof, home to stealth F-35 fighters worth hundreds of millions of dollars, were recently targeted by precise Iranian attacks. Other high-value targets, such as the Hatzerim Airbase in the Negev Desert and the Mossad headquarters in Tel Aviv, were also struck. At the center of this unprecedented Iranian assault are the Fattah and Shahab hypersonic missiles. The question arises, how did Israel's advanced Arrow-3 anti-missile system and its multi-layered air defense fail to intercept them? According to intelligence reports, the United States tracked the origin of the launches to a valley south of Shiraz in Iran, in what is considered the largest Iranian attack against Israel to date. 180 missiles were launched, traveling over 1,600 kilometers across mountains and deserts to strike their targets. The Shahab-3, a cornerstone of Iran's ballistic program, is a medium-range, liquid-fueled missile that can carry a warhead weighing between 760 and 1,000 kilograms. Its design based on North Korean technology has been adapted and improved by Iranian engineers to increase its range and precision. The missile launches vertically to optimize its trajectory towards space. After launch, it leaves the Earth's atmosphere where reduced air resistance allows for higher speeds. Once the desired altitude is reached, the warhead separates from the rocket's main body, beginning its return journey to Earth. Depending on the version, the missile can carry one or multiple warheads that re-enter the atmosphere and descend at hypersonic speeds towards their target, sometimes maneuvering to evade defenses. Another missile used was the Fattah-2, the most recent evolution in Iranian missile technology, which is equipped with a hypersonic glide vehicle. This missile can maneuver at speeds between Mach 5 and Mach 10. Although its range is 1,500 kilometers, its ability to evade defense systems makes it especially dangerous. What makes it different is that the Fattah-2 can accelerate outside the atmosphere and then re-enter to avoid being intercepted by Israel's famous exo-atmospheric missile defense system, the Arrow-3. Furthermore, its aerodynamic control surfaces allow it to change trajectory mid-flight, complicating detection and interception efforts. Hypersonic missiles are a relatively new but extremely challenging technology due to their high speeds. To understand their impact, consider that if Russia launched such a missile, it could reach the United States in just 18 minutes. China, with the development of the Dongfeng 17, is on the exclusive list of countries with this technology. Its hypersonic glide vehicle has become one of the first to enter mass production, capable of carrying conventional and nuclear warheads, becoming a nightmare for anti-missile defense systems, especially for the U.S. Navy. China even has life-size mock-ups of U.S. aircraft carriers in the Taklamakan Desert used for target practice. Although not as advanced, the United States has developed the AGM-183, an air-launched hypersonic missile. Upon deployment, it sheds its cover and uses only the kinetic energy of its glide vehicle to impact the target, meaning it carries no explosives. The U.S. claims this approach maximizes speed and reduces the chances of detection. Russia has shown its cards with the feared Kinzhal, a hypersonic missile that, according to reports, has already been tested in Ukraine and reaches the astounding speed of Mach 10. To be considered hypersonic, a missile must meet three essential criteria: speed equal to or greater than Mach 5, maneuverability mid-flight, and surgical precision. Before diving into how Iran's missiles manage to evade Israel's air defenses, it is essential to understand how the Arrow-3, the anti-missile shield in which Israel placed its trust, works. The Arrow-3 system consists of a missile launcher, an imposing structure mounted on a two-axle trailer, equipped with 6 erector tubes housing missiles ready to be fired in seconds. When fully loaded, this colossus weighs 35 tons. It also uses the green pine radar, the vigilant eye of the system, strategically located to scan the horizon for incoming threats. This advanced radar not only detects ballistic missiles at long distances, but also calculates their trajectory and speed, providing critical data to the fire control system. The Arrow-3 missile itself operates in 2 stages. Its base contains solid propellant aimed at propelling the missile beyond the Earth's atmosphere. The upper part contains the ignition chamber, which activates a chemical reaction releasing high-pressure hot gases to propel the missile at impressive speeds. The front part contains the interception vehicle, the brain of the operation. It is divided into three main sections. The propulsion system, equipped with a thrust vectoring nozzle that allows adjusting the missile's direction mid-flight, providing maneuverability to intercept targets traveling at hypersonic speeds. The warhead, which contrary to what one might imagine, does not use a conventional explosive warhead, but instead employs a kinetic impact method, destroying the target through a direct high-speed collision. Though some models include a precision explosive, charge weighing around 150 kilograms designed to fragment and increase the chances of neutralizing the threat, and the Seeker, equipped with infrared sensors and advanced guidance systems that can detect and track targets in space, adjusting its trajectory in real time and distinguishing between decoys and the real target. One of the highlighted strengths of the Arrow 3 anti-missile system is its ability to correct inaccuracies in radar detection. If the radar identifies an incoming threat but cannot determine its exact location, the Arrow 3 interceptor vehicle adjusts its trajectory in real time, increasing the chances of neutralizing the target. This is crucial when facing intercontinental ballistic missiles traveling at hypersonic speeds. If the interceptor fails to recalibrate its course based on more precise data provided by its advanced sensors, the result could be a critical interception failure. The Arrow 3 was only the first layer of defense against Iran's attacks and was expected to be the most effective. However, there are two other layers of defense: David's Sling, created to intercept medium-range missiles and drones, and the Iron Dome, famous for intercepting most short-range rockets launched towards Israel with a range of approximately 65 kilometers. Despite all this cutting-edge technology, Iranian missiles managed to penetrate all these defense layers. According to reports, Iran launched 180 ballistic missiles, some of them possibly hypersonic, as claimed by the Iranian Revolutionary Guard. Although the Arrow system successfully intercepted many of these missiles before they reached Israeli airspace, several managed to evade defenses. The main problem lies in the nature of the hypersonic glide vehicle, like that of the Fattah-2 missiles. After separating from the launcher, this vehicle can perform unpredictable maneuvers, changing its trajectory several times during flight. This evasion capability confuses radar systems and interceptors designed to engage missiles with more predictable trajectories. Neither David's Sling nor the Iron Dome are prepared to deal with highly maneuverable hypersonic missiles. As a result, the interceptors failed to reach their targets, and some missiles struck critical military bases where F-35 fighters valued at over $100 million were stationed. A single day of clashes of this magnitude has significant economic implications. It is estimated that Iran spent over $200 million launching ballistic missiles and drones. On the other hand, the Israel Defense Forces spent nearly $1 billion on defensive efforts. A cost comparison reveals the disparity. An Arrow missile costs approximately $2.5 million each, a David Sling missile around $1 million, and an Iron Dome missile between $20,000 and $100,000. In contrast, an Iranian missile has an estimated cost of $500,000, and an Iranian drone ranges between $2,000 and $50,000. The disparity is enormous, which is why Israel is investing heavily in new laser defense systems like the Iron Beam, with each interception potentially costing just $3.50.